So for this video, we're going to be looking at creating a component called game data. And so for game data, we're going to be storing the score and the health and some other different items, variables that will keep track of the game state. So we're going to be using the singleton pattern for this. If we, when we looked at that game programming patterns website, singleton is one of those patterns. So we're trying to learn the structure of the code for games, and so we're looking at game programming patterns, and singleton pattern is one that we'll be using. And what that means is that we want to make sure that we have one of these game data components, and we want to make sure it exists through the entire game. And normally what happens when you change scenes is that every game object that's in the first scene essentially stays in the first scene. Then when you open this, when you transition and open the second scene, then there are no game objects that come from the prior scene. The only game objects in the scene are the game objects that are created in that scene. But there is a way that, and essentially what we want is we want to make sure that this game database essentially doesn't get destroyed when we change scenes. So that's part of the singleton pattern, is that we want to make sure that this is this component is persistent between scene changes, so that we always just have one instance of this database. And then the other two things that we're going to do for this singleton pattern is that we want to ensure that there's only ever one instance of this game database, and we'll end up putting some components. We could put this game data in a scene for play testing, and then maybe later we end up adding a couple scenes, starting scenes that we would start from and then come to the one that we're play testing. And so we want to make sure that if we have game data created in the starting scene and then we come into this playtesting scene, that if there still is that component game data that would get created within this minigame scene, we want to make sure that as it gets created, it recognizes that there already is one and it destroys itself. So so we want to make sure there's only one instance of this game database throughout the entire game, and it's always the same one. And then also we're going to try and make it almost like a global variable. We want to make sure it's really easy to access. So that's the singleton pattern. We're going to be using a method called don't destroy on load. That's a Unity method, and that's going to make sure that the game object actually does not get destroyed between changing scenes. We're going to use static variables. So the singleton pattern, in order to have this globally accessible variable and to ensure that there's only one, we'll use a static variable, because we looked at static before and saw that static means that something's associated with the class and not with an object instance of the class. So static, right, it can be applied to a property or a variable or a method. A property, variable, method, or it could belong to the class itself. Okay, and so it means that that when we're working with a static variable, that variable belongs to the class. It doesn't belong to a specific object instance of that class. So one example would be if we were in the zombie class and we had a public static variable num zombies, then we could increment that variable. Because it's static, it belongs to the class. It doesn't, so each object instance would not get its own unique instance of this variable. There would only be one, and it would be at the class level, and that would mean that we could use that to increment this variable every time we created a game object. And so the way that we would access that would be, we would want to be finding out, okay, how many zombies are there? We would use the class name, dot notation, and then the name of this static variable. Okay, so static class, we'll be creating this utility class later, and we'll make the class static. which means that everything in the class must be static. So it's a utility class is a good example of something that would be where we would expect methods that are static. So in order to execute this method showCG, we would use the utility as the name of the class, and then dot notation, and then in this example we're using the hide CG method. So okay, so let's come back up here to our game data, and once again we're trying to have this singleton pattern, and static variables are going to allow us to do that because, well, we'll take a look and see how. Okay, so once again, this is the singleton pattern. It means one and only one of this game object, and it must exist throughout the lifetime of one gameplay session. And so those are the details of it: one and only one, globally accessible, and persistence throughout the scene change. Okay, so this, for persistence between scene changes, we're going to call this method when we're initializing this the class game data. So when we look down here, we'll look at the script, and when we have game data, we're going to initialize game data in the awake method, because lots of other components are going to be depending on this game data. So we want to make sure that game data is always initialized before any other game object that will be initializing within the start method. So any game object that has initialization in awake, we know that that will be executed before start gets executed on any game object. So that means that we know that other game objects have dependencies on this game data. Okay, so what we're going to do then, we'll just do an overview, and then we'll go ahead and take another look at what the code would look like. So we're going to create a variable. It's a static variable. The name of the data type is game data. It's the data type of the class. And we're going to name this variable instance ref. And that's just going to mean that whenever we want to access this entire class, right, which will be an object, one object, we'll use this variable instance ref. And essentially, by making it public and static, we know there's only one, and it will be easy to access. It's essentially going to be like a global variable. And then in the awake method, the first thing we're going to do is we're going to say, hey, is this variable instance ref, does it have a value of null? Because if it has a value of null, then that means that it's just been declared. It means that that's the first time that this code has been executed. And in that case, we're going to take this variable, instance ref, and we're going to point it to this object. So instance ref is going to point to the game data object that's currently executing the code. And then if that's true, that it is null, it hasn't been initialized before, then we're going to go ahead and call that method to say, don't destroy this game object. And that way we'll know that this is the one that gets executed, that gets carried through all the scenes. Now we'll find out that there are we could have another scene where we enter the scene and this game data could be executing. So we'd have another instance that's trying to execute the code. And in awake, within that scene, when we check to see if that instance ref variable is null, if it's not null, then it means that it's already pointing to an instance that was created in a prior scene. And in that case, we want to destroy the game object that's currently executing the code. So that's the trickiest part of game data, I think, is trying to understand that this code here creates a singleton object for us. Okay, so let's see what else we had up here. Okay, our static variable instance ref, right? So it's helping ensure that there's only one static variable that's associated with a class. Okay. And what we're going to do is we're going to create an empty game object, and that game object we'll call game manager, and we'll put that game data script on it, and then when we run the scene, we'll see that it gets categorized in a different kind of in the hierarchy, it'll be under this category of don't destroy on load. So it'll be clear that this is a special game object that's going to be going between all the scenes. And then one other thing for us to start thinking about is when we write methods in our code, and so far the only custom method that we've written was the flip method, and we made that private because it was only ever going to get executed in the player controller. But what we want to do now is when we know that that collision happens, right, so when we connect with that collider, we will know in the player controller that that's the event that's going to change the score or change the health, and that also needs to be updated on other game objects that are displaying that information. So we want to be thinking about this chain of events. So in order for player controller, so this is inside player controller, this is inside on trigger enter 2D, and here's what we're going to do. In order to access this game data database, we use the name of the class, and then we have the static variable, right, that we were able to use the name of the class. This is public and essentially global, and then we can call a method, and we're going to write this add method, and it'll allow us to pass in the points that are on that pickup. And so what we're doing is we're in the player controller component, but we're trying to communicate with the game data component. And so methods are how we communicate between game objects. So right now I want to make sure that we see that is that communication between game objects happens through writing functions or methods that are public that can get executed from within one class or another. So this add method that we're going to create, it's public. It's going to be executed from within player controller. Same thing with take damage. It's public. It's going to be executed from within player controller. We're going to be passing in the points associated with the pickup, and then we're either going to increase the score or we're going to decrease the health. Okay, yeah, I'm going to need to fix this. We don't have that level score and total score. I'm going to have to make a couple changes to this script. Okay, so then let's go ahead and go in here to Unity, and let's go ahead and create our script. So the name of our script is game data, and let's go ahead and open that in Visual Studio. Okay, so we're not going to use the start method. We're going to be using the awake method, and we're not going to be using update. So any method in here that gets executed, it's because it's getting executed from within another component like player controller. Okay, so let's start by looking at what are the variables, and this first variable is our public game data. Oh, and we're going to make it static, right? So it's public, it's static, belongs to the class itself, and then we're going to call it instance ref. Okay, so this is going to be our singleton variable. Okay, and then what else do we have? Well, let's go ahead and we'll start out by saying that we're going to have the score we'll keep them both as integers. Score and health, we're going to come back and add properties again. So to do so that way we can make sure that these are read-only, and it would give us a little more accessibility. Okay, so in awake, what do we need to do? Well, we need to check and see, is this variable instance ref, does it have a value of null? So the first time it gets executed, it has a value of null. So we'll say if instance ref has a value of null, then we know that this is the first time that this code is getting executed. And in that case, we want to have this variable point to the game object currently executing the code. So that'll be instance ref equals this. So this is the keyword for the object currently executing the code. And then the other thing is that once we've decided that this is the first time this is getting executed, we want to also call that don't destroy on load method. And we don't want the game object itself to be destroyed. So we'll say it's this, the game data object, and then .game object. Okay, the game object that's associated with this, it'll be the game manager game object. Okay, so now we need to do an else. So it's possible that instance ref is not null. If it's not null, then we need to destroy it. So we want to immediately destroy this game object. And let's go ahead and give us a message, a debug. We'll just say that the second one that's executing would be an imposter. So we'll eventually, when we have project 3, we'll see this code getting executed. Okay, so that's good. We're still in awake, so now we'll go ahead and we'll initialize those values for score. Okay, so score is 0, health is 100, that's the end of awake. Okay, and this is the end of game data. Okay, and then we're just going to basically have two simple methods that we want to execute when we have a collision. So these will be public. So add will be the first one, and we're going to pass in an integer. And we're just going to take the value of the score and add those points to it. And then we'll do another debug. Goodness gracious. See, the score is updated, and let's go ahead and then display the score. Okay, so that's the add method. Increases the calls within player controller. Okay, now the other one we'll say is similar. Take damage. Okay, and so for this one, we're going to take the health and we're going to subtract this, so it's minus equals value. And then let's do this. Okay, we'll say health is updated. Okay. And then we'll do one more. Let's see. Oh, you know what? Let's go ahead and do one more. Yeah, let's do one more little bit of logic. We'll say that if health is less than or equal to 0, then we want to know about that. For now, right, we can imagine that that's going to mean that the game is over, but for now, let's just do a debug message. And we'll just say health is 0. Game over. Okay. That way, we want to know when that happens. We'll get an extra message. Health is 0. That's Okay, and then one final thing is we're going to write a little method that will allow us to reset the data if we restart the game. So what would that mean? We're just going to set the score back to 0 and the health back to 100. Okay, and then that's the end of the class game data. Let's do this edit, format the document. Okay, and we'll go ahead and do a build. Okay, then we'll come back out to Unity, and once again I said we're going to create an empty game object, and we'll call this Game Manager. And to Game Manager, it's a hidden game object, but I'm still going to put that Z value there. We want to add that game data script to it. Okay, and so now we need to go back into the player controller, and here when we have these collision events, let's see, does this one not have the collision event? Okay, all right, well, I'm going to have to go ahead and put that logic back in. I'm not quite sure how I lost it, but what that was is basically saying that we want to have the on trigger enter logic again. So it's on trigger enter 2D, right? And that is telling us that we've collided, right? We said we wanted a debug. With something. Okay. And remember, we said we want to check and see what the tag is. Get the text collectible. All right, then we want to get a debug message. And we want to get that pickup component from the collision game object. So get component, the generic version, and the data type is pickup. And now we're ready to add that. So we'll do game data dot instance ref dot add, and now we want to pass in the item dot value. Okay, item dot value, and that's that read-only property value. Okay, and then we're going to destroy that game object. Okay, and now we're going to do the same thing. We'll do the else. Oops, come on. Okay, so have we connected with a hazard? If so, let's go ahead and do this. Okay, we want to say that we collided with a hazard, and we're getting that pickup script off of that game object, and instead of calling add, we want to call take damage, and we're going to pass in the same values, and then we're going to destroy the game object. Okay, so that's okay, so this was the new code that we added, right? Is that when we have the collision, before we destroy that game object, we want to get the points from that pickup. We want the value off that pickup component. So that's how we do that. So let's go ahead and do a build. Okay, and now let's come back out to Unity. Let's open the console. And then let's go ahead and do play, and we should see the game manager show up as a don't destroy on load. So there we go. We know we have a singleton now. And now let's see, as we're moving and we collide with that, okay, we're seeing not only do we get our collision here, but now the score has been updated. So that's letting us know that we did store the data. Then we can tell our health just got updated. We lost 10 points. And then let's go ahead and get our last bit. Okay, the score is now 12. Okay, so that is all for this video. Once again, it was creating this game data database, and we can see that it's a singleton because it says don't destroy on load, and we saw the easy way to access that was we just used the class name of game data, that's static variable that was public, and then we can call the method. And this is how the pickup the player controller, how it's communicating with game data by calling a method that's public in game data. Okay, so we'll stop there.